Right now, 15 billion miles from where you're sitting, a machine older than the internet is listening to something the universe was never supposed to be saying. Not a signal from another civilization, not a flash of light from a dying star. A sound. A low, steady hum buried inside the space between the stars themselves, a place every model built by every physicist for the last 50 years insisted should be silent, and the machine picking it up is not new. It is not sophisticated by modern standards. It runs on less power than the bulb in your living room, and it was built by engineers who assumed it would stop working before most of the people watching this video were even born. It didn't stop working. It kept going and going and going until it crossed a boundary no human-made object had ever crossed before, and once it got there, it started sending home a mystery that NASA still cannot fully explain. This is the story of Voyager 1, and what it found out there is not just strange. It is the kind of strange that makes scientists quietly go back and question things they thought they understood for decades. Stick with me, because by the end of this, you're going to look at empty space a little differently. And if you want more of these deep dives before anyone else covers them, hit subscribe now, because this channel exists to walk you through exactly what NASA found, not the exaggerated version floating around online. Now, allow me to take you back, where everything started, because the story only gets stranger once you understand how ordinary it was supposed to be. In September of 1977, a spacecraft about the size of a small car launched off the coast of Florida with a job that sounds almost laughably modest today. Fly past Jupiter, fly past Saturn, snap some photos, take some readings, and then drift quietly into the dark and go silent. NASA gave it a working life of 4 years, maybe 5 if it got lucky. Nobody planning that mission expected the name Voyager 1 to still mean anything by the time the 21st century rolled around. But Voyager 1 didn't stop. It flew past Jupiter in 1979 and returned images of that planet nobody on Earth had ever seen in that kind of detail. It flew past Saturn in 1980, using the planet's own gravity to sling itself even faster and even farther outward. And then, instead of falling silent the way it was built to, it just kept transmitting, through the 1980s, through the 1990s, through a length of operational life that no engineer on the original team had dared put in writing. By the time most of today's astronomers studying its data were finishing college, Voyager 1 had already become the most distant human-made object ever built, and it was still talking to us. Then, in 2012, 35 years after launch, it did something that changed the entire shape of this story. It crossed the heliopause. If that word means nothing to you, here's the simplest way to picture it. Our sun doesn't just give off light and heat. It constantly blows out a stream of charged particles called the solar wind, and that wind inflates a kind of enormous invisible bubble around the entire solar system. Every planet, every moon, every asteroid, every spacecraft we have ever launched sits inside that bubble. The heliopause is the outer skin of it, the exact point where the sun's influence finally runs out of strength, and the pressure of the wider galaxy pushes back in from outside. Cross that skin, and you are no longer in our solar system. You are in interstellar space. You are somewhere no instrument built by human hands had ever physically been. Voyager 1 crossed it, and it kept sending data back from the other side. Think about what that actually means. We have had, since 2012, a working scientific instrument sitting in the space between star systems, an environment that until that exact moment had only ever been described through theory, mathematics, and guesswork from telescopes sitting safely on the ground. And what that instrument started reporting back did not match the guesswork. Not even close. For decades before Voyager 1 ever got there, physicists built detailed models of what interstellar space should look like. These weren't casual estimates. These were carefully constructed, peer-reviewed predictions built by some of the sharpest minds in the field, and almost all of them agreed on the basic picture. Interstellar space should be cold, thin, and calm, a quiet, mostly empty corridor where particles drift slowly and not much happens, a kind of cosmic waiting room between one star system and the next. That was the expectation Voyager 1 carried with it when it crossed the boundary. What it actually found was a storm. Starting in 2017, an instrument on board called the Plasma Wave Subsystem began picking up something nobody had prepared for, a faint, narrow, but completely persistent tone humming through the plasma of interstellar space. Not a single burst that could be written off as noise, not a glitch that vanished after a few readings. A continuous signal, showing up again and again across a stretch of space so vast it's difficult to even hold in your head, tracked over hundreds of millions of miles as the spacecraft kept moving forward. Researchers who examined the readings and eventually published their findings described interstellar space as turbulent, structured, and active in ways the old models simply never accounted for, not the quiet corridor everyone expected. Something closer to a living, moving environment with its own internal weather. Sit with that for a second, because here is the uncomfortable part. Every single model of interstellar space built before this discovery was constructed from the outside by scientists standing on a planet, pointing instruments and equations at a place they had never actually touched. Voyager 1 is the first thing we have ever built that got to stand inside that place and report back what it actually feels like out there. And what it's telling us is that the space beyond our solar system has more structure, more motion, and more energy than anyone predicted, at every scale, from tiny ripples measured in meters up to enormous waves stretching for millions of miles. Here's why this stops being an abstract physics curiosity and starts becoming something that matters to every living thing on this planet, including you. That bubble the sun blows outward, the one Voyager 1 finally broke through, isn't just a boundary line on a diagram in a textbook. It's a shield. It's the thing standing between Earth and the harshest radiation drifting through the galaxy, high-energy particles thrown out by exploding stars light-years away, particles that would otherwise slam directly into our atmosphere at full strength. If the environment pressing against that shield from the outside is more violent, more unpredictable, and more energetic than we ever modeled it to be, then the natural next question is uncomfortable. How stable is that shield really, over the kind of timescales that matter for a planet, not just a human lifetime? Nobody has a complete answer yet. But the fact that serious scientists are now sitting down and asking that question at all is itself a shift in how we think about our own exposure out here. Now, before we get further into what this all means, you need to understand something else about Voyager 1 that most coverage of this story skips entirely, because it makes the discovery even more remarkable. This spacecraft almost died before it could finish telling us any of this. In 2023, something went wrong that had never happened in the entire history of the mission. Voyager 1 kept transmitting a signal, faithfully, exactly like it always had. But the signal coming back was garbage. Corrupted, scrambled, unreadable, even to a team of engineers at NASA's Jet Propulsion Laboratory who had spent literal decades learning to interpret every quirk of this machine's behavior. For 5 straight months, the spacecraft was alive and talking, but nobody could understand a word of what it was saying. The cause turned out to be almost absurdly small and almost impossible to fix. A single memory chip, roughly the size of a fingernail, buried deep inside a computer system built in the 1970s, had physically broken down after nearly half a century of constant bombardment by cosmic radiation. That one tiny failure was enough to corrupt the exact section of software responsible for packaging and transmitting scientific data back to Earth. Now imagine trying to repair that. In any normal situation, you'd walk over to the broken part and swap it out. Here, the broken part was 15 billion miles away, completely unreachable, with no repair mission remotely possible on any human timescale. The only tool available was a radio signal, and even that signal, moving at the speed of light, the fastest anything in the universe can travel, took 22 hours just to reach the spacecraft. Another 22 hours for any reply to make it back. Every single test, every attempted fix, every diagnostic step required waiting nearly 2 full days just to see what happened, all while knowing that one wrong command sent across that distance could end the mission permanently, with zero chance of recovery. For months, the team at JPL worked through that grinding, patient process, testing theories, writing new instructions, sending them out into the dark, and waiting. Eventually, they figured out that the corrupted code itself couldn't be repaired, but it could be moved. They split the affected section into smaller pieces, relocated each piece into working memory elsewhere on the spacecraft, individually verified that each relocated piece still functioned correctly from its new home, and stitched the whole system back together. It was, in every meaningful sense, remote surgery performed on a machine built before pocket calculators existed, guided entirely through a communication delay of nearly 2 days per exchange. In 2024, the signal came back clean, fully readable, fully restored, and almost immediately, Voyager 1 resumed sending back more evidence of that same unexplained hum in interstellar space. More proof that whatever this turbulence is, it hadn't gone anywhere while the spacecraft was struggling just to speak. Here's where the story gets genuinely difficult for scientists to explain away. That persistent tone Voyager 1 keeps detecting still doesn't have a confirmed cause. Researchers have narrowed it down to 2 competing explanations, and right now, nobody can say for certain which one is correct. The first possibility is that it's simply thermally excited plasma, particles naturally vibrating as they interact with their surroundings. A real discovery, but one that fits comfortably inside existing physics without forcing anyone to rewrite the textbooks. The second possibility is something called quasi-thermal noise, a different underlying mechanism entirely, one that would mean our current models of interstellar space are missing something fundamental, not just incomplete around the edges. Telling the difference between those 2 options requires either far more data from Voyager 1 itself, which is producing less every single year, or an entirely new mission built specifically to study interstellar space up close. No such mission currently exists. No such mission is currently funded. If one were greenlit today, it wouldn't even reach the heliopause for another 25 years. Which brings us to the part of this story that's happening right now, in real time, with a deadline nobody can move. Voyager 1's power is running out, and it has been running out on a schedule you could set a clock to. The spacecraft is powered by the slow radioactive decay of plutonium packed into 3 onboard generators. At launch, those generators produced roughly 470 watts. Today, nearly 5 decades later, that number has fallen to a small fraction of what it once was, and it keeps dropping by a few watts every single year, with no way to refuel it and no way to slow it down. One by one, the instruments that don't absolutely have to stay on are being permanently switched off, not because they've broken, but because there simply isn't enough electricity left to run everything at once. Every shutdown is a door closing on a set of questions that will likely never be answered, because once an instrument goes dark on Voyager 1, there is no way to turn it back on. NASA's engineers haven't given up trying to buy more time. There's an experimental high-risk plan currently underway to restructure how power flows through the spacecraft's remaining systems, squeezing out whatever small reserves of electricity might still be recoverable. It's being tested first, carefully, on the more power-stable of the 2 Voyager spacecraft before anyone dares attempt it on Voyager 1 itself, because a mistake made across that kind of distance can't be undone. If it works, some of the science currently going dark might come back online for a little while longer. If it doesn't, the timeline for silence gets shorter. And somewhere in the early 2030s, whatever happens with those experiments, the last watt of usable power will finally run out. The last readable signal will begin its journey home, and Voyager 1 will go quiet forever. But here's the detail that tends to stay with people longest. Even after the power dies, even after the last transmission ever arrives on Earth, Voyager 1 does not stop moving. There is nothing out there to stop it. No air resistance, no friction, nothing strong enough to meaningfully pull it off course. It will simply keep gliding forward in a straight line, silent, forever, carrying with it a small gold-plated disc bolted to its frame, holding greetings recorded in dozens of human languages, the sound of rain, the sound of laughter, and a map showing exactly where in the galaxy this whole strange story began. That record will still be drifting long after every one of us is gone, long after every trace of human civilization on Earth has weathered away into geology. It is, quite possibly, the most permanent thing our species has ever built, and it is riding on a machine currently kept alive with less power than the light in your kitchen. So here's what I want you to actually walk away with. Right now, in this exact moment, the only living, functioning scientific instrument humanity has ever placed in the space between the stars is nearly 50 years old, built with hardware that predates the personal computer, and it is still teaching us things that no telescope on the ground, no orbiting satellite, and no mission to any other planet has ever been able to tell us. Not because it's more advanced, because it's the only one that ever got there and refused to stop. The signal is still coming. Right now, stretched across 15 billion miles, delayed by nearly a full day of travel time, still carrying proof that the space beyond our solar system is louder, stranger, and far more alive than anyone ever predicted it would be. And every year, the window to keep listening gets a little smaller. If this kind of story is exactly what you come here for, subscribe now and turn on notifications, because we are going to keep tracking what happens next with this mission as it happens, not months later. Drop a comment telling me what part of this actually surprised you, and if you know someone who'd find this as strange and fascinating as you clearly do, send this their way. Thanks for watching, and I'll see you in the next one.